Okay, so trig inverses, we're going to do values and graphs. And the thing about the way these work is that it really is the unit circle backwards. So it says on the unit circle below, fill in the angles for quadrant 1 and quadrant 2. So let's just fill in quadrant 1 and quadrant 2 first, and then we'll deal with quadrant 4. So do me a favor and don't work ahead. So quadrant 1 and quadrant 2 only, our angles in radians are 0, pi over 6, pi over 4, pi over 3, pi over 2. And then in the second quadrant, this is a third, so this is 2 pi over 3. The guy in the middle is a fourth, so it's 3 pi over 4. And out here, this is 5 pi over 6. And pi. So that's quadrant 1 and quadrant 2. Let's just go through and do the cosine values, okay? So cosine is our x. So when I'm doing unit circle, I didn't do unit circle with you guys, so I'll explain kind of from the beginning. When x is out, so the biggest value on our unit circle is 1, right? That's the radius of our unit circle. So at 0, we're going out 1. Everything else is smaller. And from biggest to smallest, our values are 1. Radical 3 over 2 is the next biggest. At pi over 6, that's our next biggest x value. At pi over 4, cosine is radical 2 over 2. At pi over 3, cosine is 1/2. And at pi over 2, cosine is 0. So cosine is positive in quadrant 1 and negative in quadrant 2. So at 2 pi over 3, cosine is negative 1/2. That's the small horizontal value. So we're just coming over a little bit. 3 pi over 4, negative radical 2 over 2. 5 pi over 6, negative radical 3 over 2. And at pi, we're at negative 1. When we're doing cosine inverse, these are the only values we're going to use. So if you remember how inverses work, inverses have to have a one-to-one relationship. You have one x value and one y value that map together. No x's and no y's repeats. It's an even more specific function than just having, passing the vertical line test. It has to pass the horizontal line test as well. The trickiest part about trig inverses is not using the whole unit circle. And we're going to do lots with values, so if you're like, why is she talking about this right now? You'll see in the graphs in just a minute. But for cosine, this is what you're using, just quadrants 1 and 2. So that's all I'm going to fill out in quadrant 2 because we don't need it for sine and tangent. The unfortunate thing about inverses is that you use different quadrants for the different functions. For sine and for tangent, we are going to use quadrants 1 and quadrant 4. But quadrant 4 we use the negative angles instead. So let's fill in our sine values just in quadrant 1. Here, sine values are our y's. So here I'm going up none. At pi over 6, I'm going up a little. So that's 1/2 is always paired with radical 3 over 2. Radical 2 over 2 is always paired with itself. At pi over 3, we're going up a lot. That's radical 3 over 2. And at pi over 2, we're going up 1. So that's just normal first quadrant unit circle. Hopefully it's somewhere in there still. The way that sine works with using quadrant 4 is that instead of using, 7 pi over 4 and 11 pi over 6, we're going to use negative angles. So we're going to use the normal positive angles in quadrant 1. In quadrant 4, we're going to use negative pi over 6. negative pi over 4, negative pi over 3, and negative pi over 2. And that'll give, and those are the angle values that we're going to use to get our negative sine values. So sine is negative 1/2 at negative pi over 6. Sine is negative radical 2 over 2 at negative pi over 4. Sine is negative radical 3 over 2 at negative pi over 3. And negative 1 at negative pi over 2. Do you guys remember your tangent values at all? Ish, yes, yes, no, kind of. Okay, so tangent is going to use these same angles that sine uses. So positives to pi over 2, negatives to negative pi over 2. The way that Mrs. Krause and I think, both teach tangent is this little trick. At pi over 3, tangent is radical. The 3's match. At pi over 6, I guess I should have gone in order of the unit circle. Tangent is radical 3 over 3. And I remember that because 3 plus 3 is 6. Pi over 4 you just have to remember. The only other thing that tangent can be other than radical 3 over 3, 0 and undefined is 1. So, and I remember tangent of pi over 4 just because that's where sine and cosine are the same. So anytime you're dividing something by itself, you get 1. In quadrant 4 for tangent, those negatives are going to make these negative. Tangent of negative pi over 6 is negative radical 3 over 3. Tangent of negative pi over 4, negative 1. Tangent of negative pi over 3 is negative radical 3. So all of these unit circle values are things that you've worked with before. I think it's helpful to do two things. Know that we're never using the third quadrant when we're doing inverses, and kind of have these values back in your head. What we're going to be doing with inverses really effectively using them backwards. Now instead of saying what is tangent of pi over 3, I'm going to be asking you where is tangent radical 3? And you're going to say at pi over 3. Doing it backwards. Okay? All right. So review of inverse functions. With inverse functions, there are some nice properties that happen. First, with inverse functions, you have to have that one-to-one relationship, meaning that you have to have one x and one y paired together only. They have to pass the horizontal line test. And if you look at your next page of your notes and you look at the sine and cosine graphs, they fail the horizontal line test an infinite number of times because they just cycle forever and ever in both directions. So that's why we're doing this restriction. That's why we're gonna take our sine and cosine and tangent graphs and just look at a sliver of them and take the inverse of that. This is the best thing about, I think, about inverse functions right here. If you have two functions that are inverses, their domains and range switch. So if you know the domain of the first function, it becomes the range of your inverse. If you know the range of your first function, it becomes the domain of your inverse. And your x's and y's just switch. And that's the property that we're going to be using in like 30 seconds. Okay? Here's a little picture of a function and its inverse. And now we're going to do that same thing with sine and cosine.